Hello and welcome to more domain and range with functions looking at graphs today. We're going to start with interval notation, so I'd like you to pause the video right here at the beginning and jot this all down as well as these three examples. Pause and go. Okay, so interval notation is a way to represent sets of numbers. We can use closed brackets here or open brackets here, and that depends on whether or not the number is included in our set. Infinity is never included. Always use open brackets with infinity. So for example, you've done these kinds of things before. We would have written this before as saying that x is greater than -1. And that means that it goes from -1 all the way up to positive infinity. Well, with interval notation, the way we would write that is from -1 to positive infinity. Infinity is never included, so we'll use an open bracket there. So infinity is not actually a number part of the set. And then the question is, should this one be closed? Is it colored in? Is it included? Or is it not included? Should we use an open one? And in this one, because of the open circle, and it's not equal to, we use an open bracket, saying that -1 is not equal to. So this says the sets of numbers from -1 up to positive infinity, but not including -1 and not including positive infinity. The second one, we would usually write this as x is less than or equal to -1. Now with interval notation, that means it's going from negative infinity all the way up to -1. Negative infinity is never included. In this case, though, because -1 has an equal sign, it's part of the set, we will use a closed bracket, saying the numbers from negative infinity up to -1, not including negative infinity, but including -1. And the last one here, we would normally write this as all the numbers that are greater than or equal to -2 and also are less than 3. With interval notation, we just say, okay, this is between -2 and positive 3. -2 is closed, so that is equal to it. Positive 3 is open, so not equal to it. So these are all the numbers from -2 to positive 3. This is the way we can express things in what's called interval notation. Let's take a look at graphs now. Okay, you can pause to draw these two graphs if you need. This is the point 1, 3 here. This is the point 2, 2 here. You can pause it if you need. We've talked about whether things are a function or not. We know that a relation is a function if each input has only one output. We could think about the vertical line test to see, does each x value have only one y value? Will it only hit ever one time? And that is true. This one will never hit twice, so this is indeed a function. The domain is the set of all possible x values. So the x's are going this way. We look at what are the things that could be in this function that could be x values. All of these ones have x values, all the way to negative infinity, all the way up to here. These are all in, all the way to here, out. So these here are not in the domain. These are not in the set of possible x values. All of these are. So it's everything that is less than -1, and the way we would write that is we would say -1 to negative infinity. -1 here is included. Oops, I did this backwards. Stupid teacher, stupid teacher. Negative infinity all the way to -1. This one's never included. This one in this case is because it's a closed circle. And the range, now we're looking for the y values, all the possible y values, up and down, up and down. These ones down here are all in, out. So we're looking up and down from positive 3 on down. Oh wait, this wasn't -1. This was positive 1. Another stupid mistake. From positive 3 on down. So anywhere from negative infinity up to positive 3. And again, we never include this, but positive 3 is included. Okay, looking here. Is there any x value that might possibly have more than one y value? Yeah, like right here. Because this x value of 1, 2, 3, 4, 5 has a y value here and also a y value here. So that one input has more than one output. So this is not a function. The domain is every x value. We're looking left and right. Every x value that is greater than or equal to 2. So we're going to say from 2 to positive infinity. 2 is included, positive infinity is not. The range, this is going to keep going down, 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 down. This is going to keep going up, 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 up. So really it's all real numbers. You could say all real numbers. The symbol for that is this, R with a double bar. Or you could say, and we will usually say, negative infinity to positive infinity. Okay, 2 more graphs. And we are done. This one is just a set of points. And this is a crazy one called a step function. So here, pause if you need to be able to jot these down. Is this a function? Again, I'm looking. The x value of negative 3 only has one y value. The x value of negative 1 only has one y value. The x value of positive 3 only has one y value, and the x value of 3, 4, 5, 6 only has one y value. Each x has only one y. So yes, we like this to be a function. We would call this a function. Now the domain here is not a range of numbers, it's just a set of points. So we can talk about the set of points that we have. The x values are negative 3, and negative 1, and positive 3, and 6. Because it's not all the numbers in between 6 and 3. It's not all these. It's not a line or a curve that's connecting them all. It's a discrete function that has just a certain number of points. The range the same way. So we can see what's the lowest value here. That's 1, 2, 3, 4. Negative 4 is the smallest. And then 1. Uh-oh. There are 2 x's for this y. Does that mean it's not a function? No. We can have 2 inputs that both give the same output. We just can never have 2 different outputs. So this is still a function even though there's only 2 different x values for one y value. And then 1, 2, 3, 4, 5, 6. The range here, the possible y values are negative 4, positive 1, positive 6. Last example today, is this a function? Well, all of these would only have one point. Right here it gets a little tricky, but this open circle means this is not included, this is included. So really there's only one y value here for this x value, and that would be right here too. Then it's 1, 1, 1, 1, 1. Right here again, if these were both closed in, we'd have a problem. But this one's open, so the only y value that works is actually here. And then it jumps up here and it goes 1, 1, 1, 1, 1. So this is a function. Domain. Okay, what are the possible domains? It goes all the way from negative infinity up to here, and then it jumps, but this is still here, and then it jumps, but this is still here, and it goes to positive infinity. So what possible x values are included here? All of them, from negative infinity up to positive infinity. But the range is a little bit more tricky, because the range is really just here, what's that, negative 2, and then 2, and then 5. And those are the only values that y can take. So again, it's negative 2, 2, and 5. So that's how you can determine whether or not things are a function, and find the domain or range using interval notation in a graph.